In this lesson, Rails Flavored Ruby, we'll be covering some aspects of the Ruby language most important for developing Rails applications. Ruby is a big language, but fortunately the subset needed to be productive as a Rails developer is relatively small. Moreover, this subset is different from the things you'll learn in a pure Ruby tutorial, which is why if you are mainly interested in making dynamic web applications, I recommend learning Rails first, picking up bits of Ruby along the way. Of course, if you want to be a Rails expert, you'll have to learn Ruby in more depth, and in this context I particularly recommend Beginning Ruby by Peter Cooper. But you can get surprisingly far with only a little bit of knowledge of the underlying Ruby language. In order to motivate our study of Ruby, let's take a look at where we left off in the last lesson. At the end of the lesson on mostly static pages, we had just updated our application to use a site layout. Let's take a look at that. It's in application.html.erb. So I want to focus on one line in particular, this line here with the style sheet link tag. If you look at this from the perspective of an experienced Ruby developer, there is nothing particularly mysterious, but if you don't have a lot of Ruby experience, there's a lot going on right here. In particular, we have a built-in Rails method that's being called with two arguments, but there are no parentheses, as you might expect if you've seen function calls in other languages. We also have this weird thing here, this media, which is a symbol. It's a particular kind of data structure in Ruby, and this argument here, this media all, is a data structure called a hash. We'll be covering all of these ideas in this lesson. Now, knowing that Rails provides a lot of built-in helpers like this style sheet link tag, you might wonder if you're able to define a helper of your own. And in fact, you can, and we're going to make one right now to simplify this title here. So if you look at the structure of this title, we've got a base title, the Ruby on Rails tutorial sample app, and then we have the page-specific title, which we yield using the yield keyword. So let's look at one of the pages. Let's take a look at the home page. Remember, that title comes from this provide line. Here's a symbol. Again, we just saw that in the application layout. We'll be talking about that in this lesson. So we provide a title, and the page-specific title is home. So let's take a look at the result of that. Remember, Chrome doesn't actually show the title, so we're going to use Firefox here. You can see at the top here, Ruby on Rails tutorial sample app, home. Now, this is convenient, but what if we omitted this? What if we were to get rid of this line? Just get rid of it and reload. It has the base title, Ruby on Rails tutorial sample app, but then it's got this extra vertical bar, this pipe character, sort of hanging off to the right. So what we want to do right now is make a helper for the full title of the page. Let's go back and undo this. And to get started here, I'm going to run the test suite. Remember, you might have to type bundle exec there. Okay, so the test suite is passing. And now I want to make a helper. Let's take a look at exactly where it is. This is an app helpers, and now we're going to make a helper that's going to be used on the entire site. So we're going to put it in application helper.rb. So let's define our full title helper. And the full title helper will take a page-specific title, which we'll call page title. And let's just go over here and actually let's go over here and copy. We're going to get rid of this here. We're refactoring here, so we're going to be making use of our test suite. So we're going to define a base title. And we're going to say if the page title is empty, we're going to just return the base title. Else, we're going to return a string that has the base title and the page title separated by that vertical bar. Back to here, and so then what we want to do here, instead of yielding this page title, we want to call this. Remember, this is page title. What we want to do is call full title on this. So I'm going to call full title and give it the page title. So this should all be quite mysterious at this point, but we can run the test suite to show that things are still working. There we go. And now we want to have a test for that situation that we just saw. We want to have a test for the home page. We want to say that if we leave off the page title, that we just have Ruby on Rails tutorial sample app without that vertical bar. So right now we've got home. So let's write a test. Remember, it's the static pages spec. And we want to add a test for the home page. We're going to say it should have the base title. Here, we're going to remove this. And we're going to say it should not have a custom page title. So let's visit the home page. And then we're going to say that the page should not have selector title. Let's just copy this here. Should not have selector title, and the text is going to be the home with the vertical bar. And let's run the test suite again. It should be failing. Oop, it's passing, so that means we made a mistake. This is why it's good to go back and forth like this. Should not have selector. There we go. So now we've got our failing test, and we're going to get it to pass by getting rid of this line here. Good. So let's take a look at what we've done. To an experienced Ruby developer, there's not a whole lot of mystery going on here, but at this point, there's so much new stuff. What we've got here is we've got a module. We're going to add a comment saying what this does. We've got a local variable assignment. We have a single quoted string here, a double quoted string here with variable interpolation. We have control flow, if, else, end. We have what's known as an implicit return, and we have this strange looking method with a question mark at the end. So in the course of this lesson, we'll be covering all of the Ruby we need in order to understand what's going on here with the full title helper. So let's shut down these tabs here and start exploring Ruby using a very powerful tool called the Rails console. Let's start with the comment character. This is the pound sign, also called the hash mark, or even an octothorpe. They're all equivalent. Octothorpe is particularly poetic, I think. So we've got the console here. This is just a layer on top of a program called IRB, which stands for Interactive Ruby. What's cool about the console is that we have access to all of the Rails-specific commands and the Rails environment. All right, so let's type just some arithmetic. 17 plus 42 is 59. We can do an up arrow, and I'm just going to put in a comment. This is integer addition. So you can see that Ruby just ignores everything past this comment character. Ordinarily, you won't ever use this in the console, but you can, as we saw here. And in the Rails tutorial book, I have lots of comments in the console sessions. But in the context of the screencast, we're not going to need it because I'll be talking about each step as we go along. By the way, this leads to a very powerful technique in programming called commenting out. And most editors have a method for commenting out a big block. Let's take a quick look at that. Here's the application helper. If we wanted to comment out this whole title, we can just do command / in Sublime, and it comments out the thing. That's an especially powerful debugging technique. Let's close that down and go back to our terminal window here. All right, we're going to start by talking about strings. Now, strings are just a bunch of characters strung together. That's why they're called strings. And they're probably the single most important data structure for web applications because ultimately, at the end of the day, web pages are constructed by browsers using strings. So a web application does a whole bunch of stuff, potentially talking to the database, talking to external services, but ultimately what it does is it generates a string and returns that string to the browser, which is then rendered as a web page. So we'll start with an important string called the empty string. This is just two double quotes. And we can also look at a non-empty string. We can also add strings together. This is an operation called string concatenation. We can add foo and bar. Now, not all languages use the plus sign for this, and it's actually kind of a strange choice in the sense that it's not actually addition, because in particular it's not commutative. If you do this, you get the opposite. But that's the way Ruby does it, so we might as well get used to it. There's another really powerful way of building up strings called string interpolation, so let's take a look at that. We're going to start with what's called a variable binding, or an assignment. I'm going to say that first underscore name is assigned to the string Michael. Now let's make a last name, which you might guess is going to be my last name. So now we've got two variables in the local environment. Now we could build up the full name like this. We could add first name to a space character and then add last name. But a more convenient way of doing this, and I think it's more idiomatically correct Ruby, is to use string interpolation. And that uses the octothorpe, which in this context is not a comment character, but instead is used for interpolation. And then we use curly braces. So this is first name. And then we can put the space in and last name. If you've done PHP programming, this would be a $sign variable. So I prefer the second of these because I think adding a space is kind of awkward. But whereas here we can just say exactly what we mean. We have a first name and a last name, and then we just interpolate the values from the local environment. Now you might notice here that we have something returned here. This symbol here indicates the return value of the expression. In this case, it's returning Michael Hartle. But we might want to actually print that to some external device, or in this case, to the screen. So let's look at the idiomatically correct way to do that. We use the putS command. This is for put string. So we can do putS foo. We can also do this. And so notice in these cases the putS command is actually printing out the string as a side effect, and then it returns nil, which is a special value in Ruby meaning nothing. It's a contraction of the Latin word nihil, which is Latin for nothing. I should note that people do pronounce this method puts instead of putS, but it's obviously constructed in analogy with putC, which puts a character. You also might notice that in this case it didn't put in a new line. There's the printed value here, A, and then there's the return value, and they're smushed in right together. And we can actually get that with strings by doing print. So let's print foo. So you can see that putS actually doesn't just print the string, it prints the string and a new line. And we can replicate that behavior with print by putting in an explicit new line, which is written in virtually every language I know of as a \n. Incidentally, I feel that the print and putS method should be reversed. I think that print should automatically append a new line and putS shouldn't, because that keeps the analogy between putS and putC very close. It also is more in line with other languages. So for example, in Python, print automatically appends a new line. But we're stuck with putS because that's the choice that Matz, the creator of Ruby, made a long time ago. Now, you might have noticed that this entire time I've been using double quotes for strings, but Ruby also supports single quoted strings. Let's take a look at that. Here's foo with single quotes. And you might notice by default the return value of this expression, or the evaluated value of this string, is shown by default with double quotes. That's going to become important in just a moment. But for now, we can see that single quoted strings work the same way. We can concatenate them, for example. But suppose we were to try interpolating. So remember, we've got first name and last name. Let's remind ourselves. I'll actually just go up arrow. This here. Let's look at the same construction except with single quotes. See if you can guess what might happen here. So what happened here is that single quoted strings do not support variable interpolation. They're literal strings. And so this octothorpe, which is interpreted in the context of a double quoted string as a variable interpolation, in fact is just a literal octothorpe. And same thing with the braces and so on. And this is useful if you want to have a string that contains things like this octothorpe, which would ordinarily be interpreted as code. Another example is the \n, which is a new line. So we can put it. Let's print it. You can see that it just prints a new line. But suppose we actually wanted to represent \n. Well, we can print this. See if you can figure out what this will do. You can see it actually prints out \n, and then because it doesn't depend a new line, we just have the evaluation of this expression, which is nil. So we can use single quotes to define a longer string that has backslashes like this. New lines, which are \n, and tabs, which are \t, both use the backslash character. Just a backslash. So you can see the way that you get a literal backslash with a double quote is to put two backslashes. And this is what's known as an escape. You escape out the single backslash with the second backslash. And that's the same thing that happened up here. So \octothorpe escapes out that octothorpe and tells you as a user of this console that octothorpe is a literal octothorpe and should not be interpreted as string interpolation. Now, strings in Ruby are objects. In fact, everything in Ruby is an object, and we'll be talking more about what that actually means later in this lesson. But practically speaking, what it means is that we can call methods, which are also known as functions, using the dot character. So let's look at a string, foobar, and we can call the method length on it. By the way, I should note that there is a slight speed advantage to using single quoted strings, because with double quoted strings you have to go through it and see if there's anything to interpolate, whereas with single quoted strings you don't. In practice, it's extremely unlikely that that will be the bottleneck in your application, but if you see people using single quoted strings by default, that's why. So let's take a look at this. Foobar.length is 6. So what you can see from this, that the length method returns the length of the string. In the language of object-oriented programming, this string is being sent a message called length, and that message is a method that asks the string for its own length. So let's look at some of the other methods that strings respond to. We can also ask a string if it's empty. So in that case, it's false. And we can ask the empty string if it's empty, and that's true. So here we see this question mark that we saw in the context of the full title helper. This is a convention in Ruby. It's not a strict requirement, but it's very useful to have methods that return either true or false to have a consistent form. So anytime you see a method ending in a question mark, you can be confident that it's what's called a Boolean method. That is to say, it's either true or false. And these Booleans are particularly useful for control flow. So let's take a look at an if-else statement. which is probably the most common control flow in Ruby programs. So define a string s, and let's say if s is empty, we're going to return the string is empty. Else, of course, this is the branch that will be called. String is non-empty. And then we need to end the expression with the end keyword. And as you can see, it returns the string is non-empty because, in fact, foobar is not empty. So these Boolean variables can be combined using a bunch of different logical operations that are not unique to Ruby. They're used in lots of different languages. So let's take a look at some of those. Let's define a variable x, which is foo. And let's say y. Surprisingly, y is not bar. It's going to be the empty string. Oops. Empty. The power of suggestion there. And now let's take a look at logical AND. I'm going to put the string, both strings are empty, if x and y are both empty. So the way to do that is with the logical AND operator, which is 2 ampersands. So if x is empty and y is empty, we're going to put both strings are empty. Of course, they're not both empty. Only y is empty. So in this case, it just puts nothing and returns nil. Of course, it's going to return nil anyway because that's what happens when you put something. So let's try this. Let's put the string. One of the strings is empty. If x.empty or y.empty. So this is the logical OR operator to vertical bars. And there we see that one of the strings is in fact empty. And there's one final logical operation called NOT. Again, it's likely that you've seen this if you've programmed in any other language. These are very common notations. So x is not empty if bang x.empty. So this is this bang character, or this exclamation point, is not, and it's usually read bang. There it is. In fact, x is not empty. There's something equivalent to this, saying if not x.empty, you can replace that if not with unless. I suggest using whichever one of these makes more sense in terms of the way you would think about it. If you expect x to be empty, then you might want to use this one. If you expect x not to be empty, then you might want to use this one. But logically, they're equivalent. I should note that if-else is a perfectly valid control flow, but unless-else is really, really confusing, and you should never, ever do it. It will work, but it's incredibly confusing. So I strongly recommend never doing unless-else. So we've seen that Ruby objects respond to methods. And I've also mentioned that everything in Ruby is an object. So that means that even nil will respond to methods. In particular, there's a very useful method called toS that virtually every object in Ruby responds to. In this case, turning nothing into a string returns the empty string. So in particular, you can see that nil itself is not empty. In fact, you can't even call empty on nil. So this is our first example of what's called an exception. There's an error here, a no method error. There is no method empty for a nil object, which is part of the nil class. Now, this is one of the most common error messages in Rails web applications. Oftentimes, you will encounter a situation where you expect an object not to be nil, and you'll be calling some method on it, and you'll get this error. So this error is an indication that something in your program is nil when it shouldn't be. Usually that's in the context of a so-called instance variable, which we'll be talking about later in this lesson. So even though nil doesn't have a method empty question mark. We know that strings do, and so we can actually chain this. We can do nil.toS, which is the empty string, and then ask that, are you empty? And the answer to that is true. Of course, sometimes you actually want to know if an object is nil, and you might be able to guess what that is in Ruby. Let's see if we can figure that out. How might we ask, say, the string foo if it's nil? Well, we might want to say, are you nil, with nil question mark. This is the Boolean convention. And you can see that you can really guess a lot of methods in Ruby. So foo is not nil. The empty string, it's empty, but it's not nil. In fact, there's only one thing that's nil. Nil is nil. It's worth noting that in a Boolean context, nil is actually false. So let's take a look at that. I'm going to say, let's put s foobar if true. So that should actually put s foobar, right? And if false, doesn't do anything. Just returns nil. By the way, you might not even have noticed this construction. It's very natural, though, that Ruby lets you put the if statement at the end of a line. So this is equivalent to saying if true, put s foobar, end. But it's more compact if you don't have an else. If you don't have an else, and if everything fits on one line, you can just do things like this. All right, so we've got put s foobar if false, that's nil. Now let's say put s foobar if nil. That also does nothing. So in particular, nil is false in a Boolean context, and everything else is true. Other than false and nil, everything else is true. And this is possibly confusing if you've come from languages where 0 is false, but this 0 is actually true. And there's a way to convert a variable into a Boolean. So if you look at true, it just evaluates as itself. How might you turn this into false? Well, not true is the same as false. And that means that if we do two nots in a row, this is read as bang, bang, true. This should just give us true, because bang true is false, and then bang false is true. So this is a way of forcing an object into a Boolean context. So let's try it on nil. Bang, bang, nil should be false, because nil is false in a Boolean context, but everything else is true. So a string, bang, bang, foobar. Oops, probably need a parenthesis here. So it is giving us the right answer, but it's giving us a warning. So we can do bang, bang, 0. That's true. Bang, bang, 17 is true. And in fact, everything is true except for nil and false. Now we're ready to talk about method definitions. Methods are typically invoked by passing them to objects, but it's also possible to define just a bare method. There's always some underlying object on which it's called, but sometimes that object is implicit, as in the case of the application helper that we saw earlier in this lesson. Let's take a look at that again. So here's the full title method, which we invoked just as full title. We didn't actually call it on an explicit object. Right here. So this is an example of a method definition using the def keyword, and we can define a method directly in the console. Let's try that out. Let's define a string message with an underscore there, and it's going to be called on a string. So this is the argument to the method. And if the string is empty, we're going to say that it's an empty string. Notice that we're not putting these out. We're not using put s. What we're doing here is returning the value. So this is something that is true in quite a few languages, but maybe not in any you've studied before. The way Ruby works is that the last expression in a method is automatically returned. So let's this end here is for this if, and then we have another end for the def, and I'm using indentation as we have previously in the tutorial to indicate the block structure. So now let's call this method on a string message of let's just show that 2 single quotes will also be empty. String is non-empty. And I'd like to note, though, that Ruby does support an explicit return. So we can do this. So this is going to be equivalent. We're going to say return. We can actually just do this here. By the way, this is an example of when you might want to use a double-quoted string, even though you might want to use single-quoted strings by default just because they're marginally more efficient. But with a single quoted string, you'd have to escape out this this apostrophe. So there is an advantage to using double quoted strings because apostrophes show up pretty often. So we're going to return it's an empty string if the string is empty. So we can do that in one line like this. And we can return the string is not empty. Let's just do this here. Otherwise, so we could say if bang string, we could do this. There's nothing wrong with that, except that, of course, if it gets to this point, then we already know for sure that the string is not empty. And in fact, because Ruby automatically returns the last thing in the method, we could actually omit the second return as well. So it would be let's test this out. Do that, and then this. So we could actually redefine this, though. We could do this, and then we could actually just omit both of these guys. Oops, I have the wrong one there, don't I? Control C will get us out of that problem. So see, I had the wrong one here. So there we go, and then let's go to the non-empty one. Here it is. So we can omit this because if we get to this line, the string is empty. And there, because of implicit return, we can get rid of that return keyword. Let's call it another message on empty string and on, say, bar. So Ruby gives us considerable flexibility in how we define methods. And you'll see all of these used, but the most common is to use implicit return and just have the last expression be the thing that Ruby returns. So now we're in a position to understand the title helper. Let's take a look at it. So here we have a comment as indicated by the octothorpe here. Then using the def keyword, we define a method called full title, and it takes an argument called page title. And then we define a variable using assignment here, using a single quoted string. Of course, a double quoted string would work just as well. And then we say we have some control flow. If page title.empty, then using implicit return, we return the base title. Else, we use string interpolation to include the base title, and the page title separated by a space, vertical bar space. There's only one thing that we haven't talked about here, which is this module at the top. In fact, there's a second thing in this line, which is this application helper is what's known as a constant in Ruby. And you can tell it's a constant because it starts with a capital letter. Let's take a look at that. So foo here is a constant. If we try to assign to it a second time, IRB gives us a warning. It actually will do it, but it's warning us that this foo, because it starts with a capital letter, is already initialized. So in Ruby, modules are always constants, and that's what's going on here. This is just application helper. So what a module does in Ruby is it lets you collect a bunch of functionality that can then be added to multiple kinds of objects. Now, we'll be talking about that later in the lesson, but in the context of a Rails application, this application helper module is automatically included, so that anytime you define a function in one of these helper modules, it's automatically included in the views. So this is why we were able to call full title here in the application layout. And that's just something that comes for free with the Rails framework. So let's shut this down. If you're using Git, this is a good time to make a commit. So let's open up a new tab here. Look at the status. We've made some changes, and these changes are related to adding the title helper. So let's commit that. All right, and now we're ready to talk about some of the other data structures in Ruby. We'll start by looking at a useful method on strings that lets us convert strings into a list of elements. So let's take a look at that. We can look at foo and put in a few spaces. Bar baz. And I'm going to split this into its constituent parts with split. So what the split method does is it takes a string, and by default it splits on white space. In this case, they're just spaces, but it works with other white space as well, such as tabs or new lines. And the result is an array of values. So let's assign it to a letter. Let's call it A. And we can ask A what kind of object it is by giving it the class method. We'll be talking more about classes later in this lesson. So A is an array. A of 0 is the first element. A of 1 is the second. A of 2 is the third. That's potentially confusing, of course, but this is a common practice in computer science. Many languages have this arrangement, which is called zero offset arrays. The number in square brackets is called the index, and you can even use a negative index. Here's A of -1, which just wraps backwards. It goes backwards, so A of -1 is the last element, A of -2 is the second to last, and so on. We can also define an array with an array literal. Instead of doing something like a split, we can do this. A is equal to, let's just put in some numbers, 42, 8, 17. And it's useful to know that there are some aliases for commonly accessed elements. So for example, for A.first is the first element. Rails adds second. And you can also do last. We can prove that A.last is equal to A.-1 using the comparison operator double equals. So this gives us an opportunity to talk about some of the other comparisons. So let's define a variable x, which is equal to the length of the array, which is 3. And so we can verify that x is equal to 3. Now notice that this is a symmetric operation. So the double equals is commutative. X double equals 3 is the same as 3 double equals x. This is true. In particular, though, it's not the same as a single equals. 3 equals x is a syntax error. And this is one of the idiosyncrasies of modern computer languages. Virtually all computer languages use the equal sign for assignment. And that's kind of odd if you think about it, because equality definitely has this property that if A equals B, then B equals A, this symmetric quality. So you can think of equality as being an operator on the two arguments, and in that case you can think of it as a commutative operator, but assignment is not commutative. So perhaps a more natural notation for comparing two objects would be to use a single equals, but because Ruby, like many modern programming languages, uses equals for assignment, we have to use something else, in this case double equals. So let's look at a couple more examples. X double equals 1, that's false. we can say that x is not equal to 1. Remember, not is indicated using the exclamation point, so not equals is like this, and you could read that as bang equals as well. So this should be true. X is greater than 1. X is also greater than or equal to 3. But x is less than 1 is false. So all these comparisons are standard, lots of languages have them, but it's useful to know at this point that Ruby supports all of these common comparison operators. Let's look at some of the other methods that arrays respond to. Here's our array, just as a reminder. So one useful thing you can do with an array is to sort its elements. So a.sort, by default, sorts arrays according to their values in ascending order. Notice that this actually didn't change A. If you want to actually mutate the array, you can use the associated bang method. A.sort bang will actually sort the array in place. So now if you look at what A is again, it's sorted. Another example is reverse. So we can reverse the elements in an array. But you can see that didn't actually change the array. So if we do A.reverse bang, it will actually reverse it in place. Finally, I'm going to show you one of my favorite methods on arrays, which is the shuffle method. So if you do it a few times, you can see that we get different results. It's surprisingly difficult to write a correct and efficient shuffling algorithm, so it's nice that Ruby supplies this for us. Sometimes you want to add elements to an array, and there are a couple of different ways to do this. Here's the array again. Now I'm going to push onto this array an element which will also be an integer like the current elements. So a.push, and then give it number 6. We can also use another notation for pushing, which is this 2 less than signs. Let's push on the number 7. And you can actually chain these together, so let's put on both foo and bar. We see here that Ruby arrays, unlike arrays in some languages, can mix types. So you can have integers here and also strings. And in fact, arrays can contain virtually anything. You can have arrays of arrays, you can have arrays of strings, arrays of floating points, and so on. Let's see what happens if we sort this. So now we get an argument error. So this is one restriction. When you start mixing types, you might be in trouble if you try to sort it, because in this case there's no way to compare the order of a fixed num, which is what these integers are, with a string. Before we saw how to split a string on whitespace, we can actually reverse that with the join method. It's not a full reversal, of course, because it's impossible once you throw away the whitespace to get it back. Here we've got a.join with a space, and another common thing you might do is a comma space. We can see what happens if we split and then join. You can see that there's no way to invert it in general, but roughly speaking, split and join are opposites. There's another data structure closely related to arrays called ranges. Here's the range from 0 up to 9. And you can see that it's just a bare range by itself. So Ruby evaluates a range just as the range, which isn't all that useful. So what we can do is convert this range to an array with the to_a command. So there's something isn't quite going to work here. See if you can figure out what. So what happened here is that Ruby attempted to call the to_a method, the toArray, on this number 9. But 9 can't be converted to an array. There's no such method. So what we need to do here is wrap this in parentheses. And here we'll get the number 0 up to 9. One use of ranges is to pull elements out of an array. So let's define a new array. I'm going to use this useful construction %w and then square brackets. You can actually use parentheses here, and I think curly braces work too. But I like square brackets because arrays are usually written with square brackets. Foo, bar, baz, quux. This is the standard progression, by the way. Quux is a sort of a regional variant. I'm not sure where it came from, but I think it's pretty standard. But foo and bar are universal, and baz is almost always the third. If you're interested in these, you can look them up. Go to your favorite search engine and type metasyntactic variable. Okay. Here's our array. We can pull out elements 0 through 2 with a range. It's worth noting that ranges also work with characters. A up to E is just an array of characters A, B, C, D, E. We've seen some of the methods that arrays and ranges respond to, but so far they've been very simple things like converting a range to an array or sorting an array. They also respond to some more difficult to understand methods. So let's take a look at some of these. The common theme here is that these methods take an unusual kind of argument called a block. Let's take a look at an example of this. Let's look at a range 1 up to 5. And for each of the elements in this range, we're going to print out twice the element's value. The way we do this is with the each method, and each takes what's called a block. Now this is a fairly difficult idea to understand because most languages don't have it. For those of you who have a lot of programming background, this is what's known as a closure. It's essentially a one-shot anonymous function with some data attached. But I don't know anyone who's ever learned what a block is by reading that definition. Instead, in my experience, the only way to understand blocks is to see lots of examples. So this is one example. This particular block, as indicated with a curly brace, takes a single variable. So curly braces are just one way of defining blocks. And we're going to put out the string that's equal to twice the block variable. So you can see here that Ruby has printed out 2, 4, 6, 8, 10, and then returned the range. So the return value for this each method is just the original object, but as a side effect here, we've printed out the different values. There are two different ways to indicate blocks in Ruby. One is with curly braces here. The other is with what's called a do-end block. So let's try that. 1 up to 5 dot each do, and then the block variable, which is in this case we were calling I. In fact, we can call it anything we want. Let's call it number. Usually you would use a short variable, but just to emphasize that it can be anything, we're going to put out, so put s 2 times number, end, and we get the same result. And in fact, you can actually use curly braces in this context as well, but it's conventional, and certainly it's the convention in the Rails tutorial, to use curly braces for one-line blocks and do-end for multi-line blocks. If you've programmed in other languages, you might recognize that this is essentially what would be called a for loop or a for each loop, and in fact Ruby does support that syntax. We can write this as follows: for I in 1 up to 5 do, say twice I. But this way of writing things is not very common. This is not idiomatically correct Ruby. And that's mainly because Ruby really thinks in terms of objects that have messages passed to them. So if you do 1 dot 5, we're passing the each method. We're saying, okay, range, please give us each of your elements in succession. And then what we're going to do with that is up to us. We can say do I. We can put other stuff in here too. Let's put out a separator. So this is the idiomatically correct way to loop through a range. Now you might remember that we have an array variable here, foobar baz quux. Arrays also support the each method. Just put out the reverse of each of these strings. So you can see that arrays and ranges have this common structure, and an object in Ruby that supports this each method is called enumerable. And as you might guess from our brief discussion of modules, there is in fact an enumerable module that collects together all of the different kinds of things you can do on enumerable objects. Let's look at another method that's supported by enumerables. So 1 up to 5, we're going to map. And this is also a block that takes one variable. In this case, we'll call it I again. And in this case, let's exponentiate this. Ruby uses 2 asterisks for this. So see if you can guess what this might do. So what this does is it actually returns as a value. It evaluates this expression, and it returns the range 1 up to 5 with this replacing the actual range. In other words, this is just the numbers 1 up the squares of the numbers 1 up to 5. You can do this with arrays as well. Let's define a literal array of strings. Just to remind you that %w does this. This is a very useful construction. Let's map each character, call it C, and let's convert them to uppercase. We can also chain these because it's returning this evaluated value. We can chain this and map this to, just to emphasize that it can be a different letter. Let's call it, well, let's do CHAR. It doesn't have to be a single letter. Now this is just going to reverse what we did before, so this should be the original array. There we go. So this is not particularly good Ruby. You wouldn't ordinarily want to chain things like this, but you can see from this how chaining and blocks combine. By the way, the Rails tutorial mentions a way of creating random subdomains if you want to deploy your application to Heroku at a random subdomain, like subdomain.herokuapp.com. So the Rails tutorial talks about how to do that, and let's build up what that calculation looks like. So what we want is a random subdomain of length 7, composed in this case of just letters, or lowercase letters. So remember that ranges work with characters, so we can do A up to Z. Convert that to an array, and we can see that it's just A through Z. And in order to make this random, what we want to do is shuffle it. You can see that shuffles it. And then we're going to pull out the first 7. And in order to make a string, we can join them together. Of course, you can see that this here is not the same as this, and that's because of the shuffle. It's random each time. I should note that this is not the most efficient way to do this problem. What you would really want to do, if this were a long list of characters, is to pick up 8 random values and just pull out those values from the array. But for something small like this, that the inefficiency of having a shuffle is just essentially 0. So this is part of what computer scientist Donald Knuth meant when he said that premature optimization is the root of all evil in computer programming. The final 2 data structures we're going to talk about here are closely related. One of them is enumerable, and the other has essentially no properties at all. Let's take a look at this. We're going to start with what Ruby calls a hash. Some languages, such as Perl, call this an associative array. We're going to build up a user variable. We'll see later on in this tutorial that this example is not randomly chosen. So we're going to use the curly braces to indicate that this is an empty hash. Now, this is a little confusing because we just talked about blocks and how you use curly braces for single line blocks, or you can actually use them for multi-line blocks. This is completely unrelated to curly braces used for hashes, and that's just the way of things. Let's look at the class of this thing. You can see this is a hash and not a block. So hashes are a lot like arrays, except instead of using integers to index them, you can use virtually anything. So for example, you can use strings. We can have user of first name equal to Michael. and user of last name equal to Hartle. If we look at what this is, ask the console to tell us, we see here that we have two keys, first name and last name, and corresponding values, Michael and Hartle. And we can pull those out just the way we did the assignment. User of first name is Michael, and similarly for last name. Now this user hash works perfectly well, but it's not idiomatically correct Ruby. In the case of defining hashes in terms of these key value pairs, instead of using strings, it's conventional to use what are called symbols. So let's take a look at that. Let's just reset the user. And now instead of first name as a string, we're going to use first name as a symbol. So symbols look just like strings, except instead of being in single or double quotes, they're prefixed by this colon. Now, symbols are one of the most difficult to understand parts of Ruby because very few languages have them. You can think of symbols as being a pure label. They're essentially like a string, except with all of the structure stripped out. So for example, a string is composed of individual characters. Let's say a name can be split on the empty string, yielding an array of the characters. We can also reverse it, and so on. But you can't do that with a symbol. If there's no method, you can't reverse it either. You can, however, call toS on it. So you can convert a symbol to a string, but by itself a symbol has no internal structure. Let's take a look at the user again. So you can see here's a user represented as a literal hash, colon first name, Michael, colon last name, Hartle. Again, key value pairs. It's more common, though, to define a hash using this literal syntax. So let's see how that works. I'm going to reassign user. User is going to be, in this case, the key is going to be the full name, name, Michael Hartle, and then email is going to be michael@example.com. This little guy here is called a hash rocket because it kind of looks like a rocket, and it's used to define hashes. And it's pretty cool, but it's actually going away for a reason that I'm going to show you right now. This idiom is of having symbols as keys is so common that Ruby 1.9 and above define a new syntax for it. So instead of doing colon name, what you do is name colon and then the value. This automatically creates a key that's equal to the symbol name. And we also have email colon michael@example.com. Now you can see that, oh, I forgot the last name there. Let's put it in just so we can compare. So you can see from this here and this here that they're exactly the same. In particular, the console output uses the old style hash notation, so you really do have to know both. In this tutorial, for the most part, I'll be using the new hash notation, but sometimes generated code or Ruby gems will use the old notation. And in those cases, sometimes I won't change it back. By the way, as you might expect, hashes can be compared. Let's just look at this as the old style notation, and let's do user2. User2 with the new style notation. We can verify that user is equal to user2. That's true. And two hashes are equal if and only if they have the same keys and values. As with most other Ruby data structures, hashes are extremely flexible, and they can contain virtually anything inside them, including other hashes. So this is an important enough example in Rails programming that it bears a little bit of extra scrutiny. Let's take a look at this. I'm going to define a hash called params. It started off as an empty hash. And now I'm going to say that the key, of course, with the symbol user is going to be equal to another hash. And I'll define this with the new style. Name, Michael Hartle, email, at michael@example.com. And so now if you look at what params is, as you might guess, this params is short for parameters, and it's used extensively by Rails. So here we have a hash with one key, which is the symbol user, and value equal to another hash with two keys, name and email, and two values, Michael Hartle and michael@example.com. So we can pull out, for example, the email here, like this, params of user, and then email. So these nested hashes are a very common data structure in Rails applications, so it's a good idea to start understanding them even at this early stage. Like arrays and ranges, hashes are enumerable, which means that we can iterate through them using the each method. Let's look at an example of another hash. It's called the flash. Again, this is not randomly chosen. We'll see later on in this tutorial that this is used by Rails. And we'll have two keys, success, which will be the string "it worked," and an error key, "it failed." So let's iterate through this. Now before we had a range or an array .each, and then we had a block do where we took a single variable. We called it like I before. But if you think about it, hashes have a more complicated structure. Each element in the flash here, in a hash generally, consists of a key value pair. So instead of just a single variable like I, we're going to have the key and the value. Let's put s key, and let's interpolate the key. Has value. So you can see here we printed out key success has value, it worked, key error has value, it failed. Now, if you think about these as sentences in English, though, ordinarily what you would want to do is put success in quotes, or maybe have like a colon success and then has value, it worked, in quotes. And there's a way to do that in Ruby, which is to call what's called the inspect method. So what happened here with this output is that when we have this variable interpolation, the key and value are both being converted to strings. The values are already strings, but these symbols are also being converted to strings, which is why the colon got stripped off. And it would also be nice if we had these literal strings, as I mentioned before. So there's a way to do that in Ruby using what's called the inspect method. So now we have key colon success has value, quote, it worked, and similarly for error. So let's just take another look at that at the console. Let's put s foobar as a string. It's just going to put s foobar without the quotes. If we call inspect on it, it keeps the quotes. So this lets us see what the object actually is. This is even more useful in the context of arrays. Here's an array. If we want to put SA, you can see what Ruby does. It actually puts each of the individual strings out. But that's probably not what we want. What we probably want, if we're printing out an array, is to see what the array actually looks like. And so you can say put sa.inspect to see what it actually is. This is common enough that there's an alias for it. It's just the letter P. So if we do PA, it's the same as doing put sa.inspect, although there's a slight difference. You can see here it actually does return the object itself. But it has the same side effect, which is to print out the inspect version of the object. Now that we've talked about hashes and symbols, let's take another look at that CSS from earlier in the lesson. So this is a line to include the application style sheet link tag, application, media all. Now, some of this is still somewhat obscure. We'll be talking more about this line in later lessons. But for now, we can see what we've got here. Let's run our test suite. This is the entire suite for now. There's only one file. So we've got 9 examples, 0 failures. So this line has a built-in Rails method, and then it has a string here and a hash. But if you think about it, this doesn't look quite right, because if this is a method call, it should have parentheses. And if this is a hash, it should have curly braces. So let's run our test suite again and verify that this still works. If this were a syntax error, so for example, if I were to leave off one of the curly braces, we would get a failing test suite. So this embedded Ruby here is calling the stylesheet link tag on 2 arguments, on a string, which is just the file name of the CSS file, and then an options hash that says this is for all media. So this is for print and for computer screens and so on. And so there are a couple of things that we can infer from this. One is that the parentheses are optional, so we can remove them, and these spaces are just to line these 2 things up. So this looks nice to have these guys aligned. So we can put in those extra spaces and get rid of this. We can again run the test suite just to verify it's still working. And when a hash is the last argument in the argument list, we can omit the curly braces. Let's do this here. As a final touch, I'm going to convert this to our new style hashes. There we go. And it should still be passing. By the way, we can look at the source of this page. Let's take a look. So this style sheet link tag produces this line here. If we click on this, we can actually see what the application style sheet looks like. And in fact, it's empty apart from this comment. We'll set about changing this in the 5th lesson. In this section, we're going to dig a little deeper into the idea of an object in Ruby, including the idea of Ruby classes. And in the process, we're going to define our own class in order to get a better idea of what's going on. We'll start by revisiting some of the built-in Ruby classes, and we're going to talk about how you can use Ruby to make a new object of a particular class, a process known as instantiation. So we saw before how we could make a string using a literal constructor. We did similar things with arrays and with hashes. We can see that this object is of class string. But there's a second way to create a new string, which is to use the string class itself. So let's see how that works. The way you make a new Ruby object, once you know the class name, is by using the new method. String.new, and then we give it the string. And this has the same effect as the assignment at the top. Similarly, we can make a new array by calling array.new and giving it the initial array. You can see here that the constructors for string and array just take the value that we want the variable to have. In this case, the string foobar. In the second case, the array 132. Hashes are different, though. Let's look at a new hash. This is just an empty hash, and we can access one of its keys. This is something that we haven't talked too much about before, but by default, if the key doesn't correspond to any value, it's just nothing. It's nil. Suppose instead we did hash.new and gave it a default value, 0. in this case. Now h of foo is 0 by default. So you can see that hash.new doesn't take the object itself, it takes the default value that corresponds to a hash whose key has not been defined. You might remember that we called methods on objects. So for example, we can call length on a string. This kind of method is called an instance method. S is an instance of string, and length is a method called on that instance. There's a second kind of method, which we've just seen, string.new. In this context, the new method is a method on the string class itself. This is what's known as a class method. One of the most powerful ideas in object-oriented programming is the notion of inheritance. Let's take a look at what that means in the context of Ruby. Let's start with a string, in this case foobar, and let's ask it what its class is. See, it's a class string. But we can ask what the superclass of this is. So in other words, what is a string? Well, a string, it turns out, is an object. We can, as we find by calling superclass on it. We can call superclass again to discover that an object is a basic object. Let's call superclass again. Basic object is at the bottom of the hierarchy. Let's take a look at a diagram of this. Here we've got a diagram showing the inheritance hierarchy. We've got a string, which inherits from object, which inherits from basic object. You might wonder what the difference between object and basic object is. This is new in Ruby 1.9, and a basic object is essentially an object with absolutely no structure. Object has a bunch of extra stuff that comes as part of what's called the kernel module. And it turns out that if you want to define your own object hierarchy, sometimes you really want to avoid the things that come for free with object. And so with earlier versions of Ruby, people would find themselves taking an object and stripping out all of the stuff they didn't want and then inheriting from that. So in Ruby 1.9, they added basic object so that you didn't have to do that. But as you might guess, though, everything in Ruby ultimately inherits from basic object. And this is what it means to say that everything in Ruby is an object. To understand this a little more deeply, let's define our own class. We'll start with a function that will be defined on strings. We're going to be using the notion of a palindrome. So a word is a palindrome if it's the same spelled forward and backward. Well, let's define a word class to capture this idea. Let's do class word. We're going to define a palindrome method that will tell us if a string is a palindrome or not. It's a Boolean method, so we'll put a question mark at the end. And we'll say it's going to take an argument, which is a string. And a string is a palindrome if it's equal to its own reverse. So string double equals string.reverse. So now let's create a new word, which is to say an instance of the word class. By default, there's a new method on this word class, and all it does is return a bare word object. We can call palindrome on it, give it foobar, which is not a palindrome, and let's give it level, which is a palindrome. We can examine the class hierarchy. It's a word. Superclass is object. Superclass of that is basic object. Now, if you were confused here, that's actually a really good sign, because this is a really stupid thing to do. There's absolutely no reason to wrap this palindrome method inside of a word, because we actually haven't captured the notion of a word at all. If you think about what a word is actually just a string. And so what we really ought to do here is express that idea in code by having word inherit from string. Now, we're going to get an error if we try to define a new word class, so I'm just going to exit the console and start it up again. That clears out all the old definitions. And now I'm going to say that word is going to inherit from string. This less than sign in this context refers to Ruby inheritance. And what that means is that every instance of word, that is to say every word object, is automatically a string. So let's define our palindrome. Now in this case, we don't actually need to have an argument, because since a word is a string, we automatically have access to the string itself inside of the class. And Ruby uses a special word that's common in object-oriented programming called self in this context. So a word is a palindrome if the word itself is equal to the reversed version of that word. And so now we can create a new word. Notice now we actually do instantiate it with a string. And we can now interrogate that word. We can say, okay, word, are you a palindrome? And the answer is yes. W.palindrome ? Is true. Now it's important to note that because word inherits from string, words are in fact strings, which means we can, for example, ask them what their length is. In this case, 5. And we can verify the class hierarchy as follows. So the class is word, the superclass is string. So of course at the bottom of that we have the class itself, which is word. Let's take a look at a diagram. So this is the inheritance diagram for word. You can see it's the same as the diagram for string, except word is at the bottom. Word inherits from string, which inherits from object, which inherits from basic object. Now there's one more thing we can do here. If you think about it, the notion of a palindrome actually doesn't apply just to words, but to any kind of string. So 1001 is a palindrome, for example. You also might note that we can't actually call the palindrome method on a literal string. So level, which is a palindrome, doesn't have a palindrome method because strings don't know anything about palindrome. Only words do. It would be really nice if we could add this palindrome method itself to the string class. So we'll see how to do that. Well, we can just say class string and define the palindrome. So this is the same thing we saw before. The string itself is a palindrome if it is equal to its own reverse. So now we can say s is equal to a new string. We can ask it if it's a palindrome, and it says false. Now, notice this is really amazing, because we can actually still do the same thing, s.length, and so on. So this string is just a normal built-in Ruby string with an additional palindrome method. And in fact, we can use a string literal as well. Deify.palindrome ? And we see that we've successfully added the palindrome method to the string class. So this is something that you won't find in a lot of other object-oriented languages. But Ruby actually lets you open up the built-in default classes and add your own methods. Among other things, this lets us discover the amazing fact that the word deified is a palindrome. Now, as you might imagine, opening up the default Ruby classes and adding things or changing things around is potentially very dangerous. So if you were to, for example, redefine multiplication, you would be in trouble, right? Like that would really screw things up. So you should only add methods if there's really a good reason to do so. Rails does have some good reasons, though, and so let's take a look at an example. This is a really useful method called blank. So the empty string is blank. So is a string of just white space. So this is something that's actually added by Rails to Ruby. And the reason we have access to it is because we're not using interactive Ruby by itself. We're actually using the Rails console. There's one other thing that's blank. Nil is also blank. So this is a really useful method. In fact, this is so useful that several years ago I added it to a Rails project, not knowing that Rails had already added it. And it turned out that I hadn't included the relevant module. And I was wondering, like, why is this working? Because once I discovered the module wasn't included, it didn't make any sense at all that blank question mark was actually doing anything. And it turned out that it was actually defined by the Rails framework. Let me show you one more example. Let's just take something like 1. So 1 is a fixed num. Fixed num is an integer, which is a numeric class, which is an object, and then that inherits from basic object. Rails adds some methods to fixed nums. We can do 1 megabyte, which tells us how many bytes in a megabyte. In particular, it's not a million, it's actually 2 to the 20. Rails also adds some really cool date helpers, so we can do something like 20 years ago, 20.years.ago. And we could also say from now. So these are the kinds of things that would be very difficult in other languages, but are quite easy in Ruby. Now, we've been talking a lot about classes and about class inheritance. And so you might have noticed in our previous lessons that we actually encountered these ideas. Let's take a look at our static pages controller for an example. So here's the static pages controller. And now we see that this is a static pages controller class, and it inherits from application controller. And then it's got these methods inside, which are the home, help, about, and contact actions. Now, you might think about this for a moment and realize that since we are in the Rails console, we actually have access to this class. And we can, in particular, make a new controller right here in the console. We can say static pages controller.new. And in fact, we can ask it its class, superclass. So we're going all the way up the hierarchy. And finally to object, and then to basic object. We can visualize this hierarchy in this diagram. At the base we have static pages controller, and then we have a bunch of classes defined by Rails. So application controller, action controller base, action controller metal, abstract controller base, object, and then basic object. Now I should emphasize that you don't have to know about most of these things. The only thing I know about here is application controller. I know a little bit about action controller base. I know very little about anything else, in particular metal and abstract controller base. I could dig into the Rails documentation or the Rails source code to find out more about them. But the truth is that as a Rails application developer, you'll almost never have to deal with anything other than things that inherit from application controller. Now, as we see in the static pages controller, there are a bunch of methods here. Since we have an instance of static pages controller, we can just call one of those methods. Let's do that. Let's call the home method. We see that it returns nil. But wait a minute, that's not what happens when you call the home action in the context of a Rails application. In a Rails application, calling the home action renders the home view. You might also note that at no point in the sample application have we called static pages controller.new, and in fact we'll never do this. That's not something you ever do with a controller. So what we're discovering here is that while Rails is written in Ruby, Rails is not the same thing as Ruby. Rails is a framework for making web applications. It's a directory structure, it's a bunch of utilities, and it contains within itself a domain-specific language, or DSL, optimized for writing web applications. What that means, though, is that some of the behavior that you would expect as part of a plain Ruby class is not what you get as part of a class when it's part of a Rails application. This is why I recommend that people who are principally interested in making web applications start with Rails, picking up enough Ruby along the way to get by, and then only later go back and study Ruby in more depth. We'll end our discussion of Ruby objects with the creation of a full class from scratch. In contrast to the previous parts of this lesson, we're going to use a file that contains a class for users. As you might guess, in a later lesson, we'll define a real user within the Rails framework, but for now, we're just going to make an example user. So let's quit out of the console, and let's open up a user class. Let's call it example user. .rb for a Ruby file. And now we'll define a class from scratch. So class user. And at this point, we want to talk about what sort of attributes this user will have. And previously, you might remember that we talked about a user hash that had a name and email address. So let's define those attributes for this class user. The way to do that is using a special Ruby method called attr_accessor for attribute accessor. And what we do is give it symbols corresponding to the attributes we want our class to have. In this case, name and email. And then we need to define the constructor. This is what will be executed when we call user.new. The name of this method is initialize. By the way, I don't know why it's not just called new, but it's the way it goes. And we're going to initialize, in this case, our user with a hash of attributes. Now, by setting this attribute's argument equal to the empty hash by default, we arrange for there to be a default value, which means that if we call initialize with no arguments, it will just be the empty hash. And now we're going to define a couple of instance variables. @name is going to be attributes of the name key, and email @email be attributes of email. I'm throwing a lot of syntax at you right now, so it would be surprising if you understood this all. So we'll examine what this means in a moment. And now I'm going to define an instance method. This is a method on user objects, and I'm going to call it formatted email. And what it's going to be is just the name and then the email address in angle brackets. This is the way you might see an email address formatted inside a mail program. So in order to do this, I'm going to use variable interpolation, or string interpolation. Here we go. It's going to be the name, and then in angle brackets like this, email. Oh, and I need to be @email. Now, you might recall that we've actually seen these instance variables before in the context of the demo app. Instance variables, when they're defined inside of controllers, are available inside the Rails views. So in this example, we see what instance variables are in a deeper sense. In Ruby, when you have an instance variable inside of the initializer here, inside of the constructor, these variables, these @ variables, are automatically available everywhere else inside the class. And so by defining @name and @email, we automatically gain access to them inside of this formatted email method. So let's see what this does. We can load this example user class using the require keyword. Require, I'm going to do // this is the full path. It's dot is the current directory. On some systems, you can actually omit the // but this is the way to do it cross-platform. So I'm going to require example user. Notice I don't do example user.rb, just example user. Now I can create a new example user. Let's just call it user. User equals user.new. So let's see what the user's name is. It's nil because it's not defined by the constructor. User email is also nil. So this is because the attributes hash over here is empty. So remember, when we try to access a key that isn't defined, the result is just nil. So what happened here when we called user.new is it ran initialize, and it ran it with an empty attributes hash. And so @name is empty. It's just nil, and @email is also nil because the name and email keys don't exist. So you might ask, well, how does the user object know to respond to this name method? How is it possible that it has this attribute? Why does user.name pull out @name? And the answer is that's what @accessor does. Or at least that's one of the two things that @accessor does. Actually, what we're doing here is just reading the values. And in Ruby, you could express that with what's called @reader. So user.name pulls out @name, and user.email pulls out @email. But because it's not just @reader, it's actually @accessor, we can do one better and actually assign to name and email. So we can actually assign this name and assign the email. And now if we look at the formatted email, we get example user @example.com. And so you can see what happened here is that the assignment to user.name and user.email set these variables, @name and @email. In the context of object-oriented programming, this user.name is what's called a getter method. This gets the value of the name attribute. And this here, user.name equals, is a setter method. So getters and setters are part of the boilerplate of object-oriented programming, and this @accessor line abstracts away that boilerplate so that we don't have to write it ourselves. Let's look at one more example. Instead of instantiating a user with an empty attributes hash and then assigning the attributes explicitly, let's instantiate it with an initialization hash. User equals user.new, and then we're going to say name is my name and email mhartel@example.com. And now we can call formatted email on that object, and we get a nicely formatted email. So what happened there is the attributes hash did have values corresponding to the name and email keys, and so then formatted email just pulled out those instance variables. There's one more thing worth noting about instance variables. Unlike normal variables, they're nil by default. Let's take a look at that. Let's look at the variable foo. This is a name error because there's no local variable called foo. By the way, you notice that here is main. This is the environment in which the Rails console executes. And you can see that main is actually an object. So this is yet another example of how Ruby is objects all the way down. Everything is an object, even this environment in which the console runs. So foo as a local variable is undefined, and if we try to access it, it gives us a name error exception. But let's look at @foo. So @foo is nil. One of the common errors you'll find in Rails applications is when you are trying to do something with an variable in a view, and you'll end up with a nil that you weren't expecting. So for example, if I were to call name on @foo, I get a no method error, undefined method name for nil class. This happens in tests as well, and it's usually a sign that you didn't correctly instantiate one of your variables in the controller. So if you have, for example, an @users variable in one of your controllers and you forget to define it, then you'll get this kind of error. So anytime you see an undefined method for nil class in a Rails application, the chances are pretty good that you just forgot an assignment somewhere. This brings us to the end of our overview of Ruby. There are lots of great online resources for learning more about Ruby, and I especially recommend just looking at the Ruby documentation. So let me show you an example of that. Here I've gone to the web page for the Ruby core reference. This is, you can see the URL here, it's ruby-doc.org/core-1.9.3. So this lets you look at the built-in classes and methods. So here's string. And if you scroll down here, you can see all of these methods that strings respond to. And it's got a little bit of documentation showing you how to use these methods. So you can learn an awful lot about Ruby just by picking one of these classes, say string or array or hash, and just going down and reading about them. They've got these examples. So for example, if you've got this string times an integer gives you a new string. So if you multiply the string ho times 3, you get ho, ho, ho. And you can verify this. And at this point, you might notice that there's an extra space here at the end. And you think, well, how might I strip that off? And if you read down, you'll learn that there's something called strip that returns a copy of the string with leading and trailing white space removed. So we can do this. We need to put it in parentheses, otherwise it would call it on 3. So that stripped off the white space there. In fact, there's another method called rstrip, which just strips off the right part, since that's all we need here. So these are the kinds of things you can learn just by reading the Ruby documentation. And I recommend going online and reading especially about strings, arrays, and hashes, the 3 principal data structures that we talked about in this lesson. In the next lesson, we'll apply some of the things we've learned about Ruby to the development of the sample application.